Welcome to today's lesson. Today's lesson is on preventing heat loss. The aim of this lesson is to be able to describe ways to stop heat loss from the house. You're going to need the assignment up to answer questions as we go through the video. First of all, I want you to pause the video and work your way through the Do Now activity that's already on the screen. Okay, let's start with the first question. What is the national grid? You should have put that as a series of power stations, transformers and wires that work together to deliver electricity to the consumer. An advantage of the national grid is that it responds to the high demand and is also reliable. A transformer changes voltage and current as you go across the national grid when needed. For an advantage and disadvantage for underground wires, you could have put for advantages, it prevents heat loss, it's hard to steal, and it's good for built up places because it's safer. For disadvantages, you could have said it's either expensive to install or repair. Right, we're going to start with a recap of the movement of thermal or heat energy. First of all, let's note that heat energy and temperature are not the same thing. Temperature is the measurement of how hot something is. We also need to be aware of the units that heat energy is measured in, and this is joules. Thermal or heat energy will move from somewhere hot to somewhere colder by either conduction, convection, or radiation. We're going to watch a short video that describes conduction, convection, and radiation, and then answer a series of questions based on it.
Whenever an object is heated, energy is transferred to its thermal energy store, and its temperature increases. The process of heating, though, can take place in 3 different ways, depending on the medium involved. For solids, heat is transferred by conduction. In fluids, it's via convection, and to get through empty space, heat has to be transferred in the form of radiation. Let's start with conduction. The key idea behind conduction is that vibrating particles transfer energy to neighboring particles. To understand how this works, let's imagine that you were heating one end of a piece of metal with a Bunsen burner. And imagine the piece of metal as a series of particles. As the end of the metal is heated, energy is transferred to the metal, or more specifically, is transferred to the kinetic energy store of the particles at that end. This causes the particles to vibrate faster, and so they collide with their neighboring particles more often, and with more energy. As the collisions transfer kinetic energy, the neighbors will also vibrate faster, and collide more with their neighbors. And as this process repeats, energy is passed along the piece of metal, until in the end, the heat is spread out evenly, and it will be pretty much the same temperature everywhere. Now, the reason that conduction occurs mainly in solids is because the particles in a solid are held together really closely, which means that there's lots of collisions that pass on the energy. Whereas in liquids and gases, the particles are all further apart, and so they don't collide as much. Exactly how well objects transfer energy by conduction is known as their thermal conductivity. Metals have a high thermal conductivity, and transfer heat energy rapidly, whereas plastics have a low thermal conductivity, which is why we use them as insulators. And pretty much all fluids have a low thermal conductivity. Convection, on the other hand, occurs mainly in fluids, and remember, fluids can refer to anything that can flow, so both liquids and gases. Because the particles in fluids aren't fixed, once they're heated, and they gain kinetic energy, they all move around faster. By the process of random diffusion, this will cause these more energetic particles to move away from the warmer region towards the cooler region. And overall, this means that the higher energy particles in the warmer region are a lot more spread out than those in the cooler region. So effectively, the fluid in the warmer region actually expands as it heats up, and so becomes less dense than the cooler fluid. To understand how this works in real life, let's imagine that we had a container of fluid, so that could be either liquid or gas. As we heat the container, the following things would happen. First, the particles near the heat source would gain kinetic energy and spread out, becoming less dense. Because they're less dense, these particles rise above the colder, less dense particles above them. And at the same time, these cooler particles sink down and take their place. Whilst this is happening though, the hot particles will lose their energy and cool down, and the cool particles now at the bottom would heat up. Because of this, the cycle would keep on repeating for as long as the fluid was being heated, and we call this cycle a convection current. We actually see these convection currents all over the place, from oceans to inside buildings, where radiators warm the nearby air and set off the cycle. On the other hand, to reduce convection, we need to stop the free flow of fluids, which is all we're doing when we sleep under a blanket at night, which is stopping the warm air from escaping. What conduction and convection have in common is that they both involve particles gaining kinetic energy. It's just that in conduction, only the energy is transferred between the different particles, whereas in convection, the particles themselves move. However, heat energy can also be transferred without particles, which means it could travel through a vacuum. This happens when energy is transferred by radiation, and specifically when the energy is carried by infrared waves. All objects constantly absorb and emit radiation, and in reality they do both at the same time. Importantly, the hotter the object is, the more radiation it emits. This is why it feels hot to put your hand over a barbecue, even if you're not touching it. The very hot metal and coal is emitting infrared radiation, which is absorbed by your hand. We'll take a closer look at infrared radiation when we cover the electromagnetic spectrum.
I now want you to pause the video and have a go at answering these questions on the assignment. Okay, so looking at the first question, how does heat move in solids? In solids, heat energy is transferred by conduction. For both B and C, because they're liquids and gases, they're both fluids, so they'll transfer heat by convection. And for D, through a space or through a material medium would be radiation. When particles are heated, what energy causes them to collide with other particles? This would be kinetic energy. Particles in solids and fluids are ordered differently. In solids, they're a lot closer together, but in fluids, they're spread out. What is meant by a good thermal conductor? An object that is good at transferring heat energy by conduction is a good thermal conductor. An example of this is metals. In convection, warm air will rise. And the last one, do hot or cold objects emit more radiation? This would be hot objects. Okay, we're now going to look at energy transfer in a house. So as we can see from the thermogram, there's areas which are hotter, and this is in the colour red or orange. So you can see the roof, this has a lot of heat, and also the walls and near the windows. The areas where it's hotter will be the areas where most heat energy is lost. If we want to understand how we can prevent heat loss from the house, we must first understand where and how the heat is lost. So first of all, we'll look at conduction. Near the floors, the roof and the windows, energy is lost by conduction. And because windows and doors have gaps allowing cold air to enter, these convection currents will cause hot air to rise to the loft and transfer heat energy to the roof tiles, and then heat is lost. The walls, roof and windows also lose heat energy by radiation. However, there's a ways of preventing this heat loss. So first of all, we'll look at loft insulation. Looking back at the thermogram, we can see that the roof is one of the hottest areas, and hence these will be the areas where lots of heat is lost. There's lots of heat here, as we talked about before. Convection currents in the house will cause the warm air to rise to the roof. We can fit loft insulation to reduce this heat loss. An insulator is a substance that does not allow energy transfer very easily, and they're very poor conductors. So if we look at this image, we can see how the insulated loft works. So insulating materials such as mineral wool or fiberglass is fitted between the gaps in the roof. This material is a really bad conductor, so reduces heat loss by conduction, and the material also prevents air circulation, which we learned from the video that to reduce convection we need to stop the free flowing of fluids. Okay, we're now going to look at cavity wall insulation. So as we can see from the image, the outside wall and the inside wall has a gap between. This is known as the cavity. But we can fill this space with foam, and this foam traps air, which is a very poor conductor, and also stops air from circulation, reducing convection. So the cavity wall insulation stops heat energy loss by conduction and convection. We're now going to look at double glazed windows. Let's look at the thermogram. In single glazed windows, you can see from the image that the windows are red, hence they're really hot. But in the double glazing, they're green, showing that they're less hot. So the double glazing works by having two panes of glass to create an air vacuum between. And as we just learned, air is a really bad conductor, so heat loss will be reduced by conduction. And it also stops the air from circulating, reducing convection. Floor insulation works in a very similar way to the loft insulation. Mineral wool can be laid between the joists underneath the floorboards, and silicone sealant is used to seal the gaps. This material, as we've already learned, is a poor conductor, and because we've sealed the gaps, there's no cold air flowing through, reducing convection. Draught proofing is the next type of insulation we can install in the house to reduce heat energy lost. So first, let's talk about what draught is. So a draught is a current of cool air in a room or in other confined spaces, therefore causing convection currents and heat energy loss. However, we can install draught excluders or proofing strips and put them between the gaps under the doors and window frames to stop this cold air coming in and therefore stopping convection. So draught proofing stops heat energy loss by convection. Some other insulators are fitted carpets and curtains. So fitted carpets, the material is a really poor conductor, stopping heat energy loss by conduction. And curtains, just like a warm blanket, what you sleep under, stops the convection currents. In this diagram, we can see which areas of the house lose different percentages of heat. Okay, so I now want to pause the video and rewind as many times as you need to fill up this table. So across the top, we've got types of insulation. We've already talked about double glazing, loft insulation, floor insulation, cavity wall insulation, and draught proofing. You need to tell me how each one works and what heat energy does it stop or reduce. So go ahead and pause the video and rewind to different points to fill out the table. Okay, the next activity I want you to do is write conduction, convection, or radiation by each statement. So pause the video, do that on your assignment, and then come back. Okay, so we'll start with the first one. Happens in solids. We know this is conduction. So metals are a good form for this type of heat transfer. Again, that would be conduction. Heat transfer in fluids is by convection through convection currents, and causes warm air to rise is convection. So heat is lost from the roof by both conduction and convection. Filling cavity wall with foam reduces this. So this is talking about cavity wall insulation. And as we learned, that foam is a bad conductor, therefore reducing conduction, and also stops the air moving, so stops convection. Hot objects emit more of this. This would be radiation, and happens between a space or through a material medium would also be radiation. Air vacuum created between two panes of glass reduces this. So this is talking about double glazing insulation, and because it creates an air vacuum, it traps air, which is a bad conductor, stopping conduction, and because the air is trapped, it stops the circulating of air, so stopping convection. Okay, the next few questions are going to be exam questions. In your exam, there'll be a lot of questions on heat energy transfer, so it's really important that we start now so we can master answering them and get the marks. So I want you to pause the video and go through by yourself trying to answer these questions, and then come back to the video. Okay, as you can see, I've highlighted the important bits of information. This is a really good way of answering exam questions because it means you'll never miss out key information and you always know what you're doing. Okay, so the Welsh Government Warm Home Schemes called Nest aims to make the Welsh homes warmer and more energy efficient place to live. Nest is accessible to all homeowners in Wales and provide advice on saving energy. Drafts, floors, windows, walls, and the roof are the 5 ways energy is lost from the heated house. The pie chart shows the percentage of energy lost by each of the 5 ways. Use this information below to complete the labelling on the pie chart. One label has been completed for you. So we'll start with the first one. The percentage energy lost through the walls is greatest. So if we look at the pie chart, we can see that 35% has the most heat loss. So this is going to be walls. Write this in. So I'll write walls here. The next one, windows and drafts have equal percentages of energy loss. So if we look at the pie chart, we can see that drafts already been done for you, which is 15%. So equal to that is going to be 15% again. So this is going to be the windows. The next one, windows and floor percentage losses add up to equal the percentage lost through the roof. So if it adds up to the roof, we know that the biggest one left is going to be the roof, which is 25%. So put roof here. And then so the 10% must be the floor. And if we add the 15% and 10%, it does make 25%. So that's right. Well done if you got that right. Okay, for this question, we're going to start exactly the same by highlighting key bits of information. So to reduce energy loss through the roof, so we're now talking about the roof, the Nest scheme suggests the installation of fiberglass. Explain how, so explaining, fiberglass reduces energy loss in the loft by convection. So now we know we're talking about fiberglass and how it reduces energy loss and by convection, so we're not talking about conduction. So remember to read the question fully. So the first point we want to make is that the fibres of insulation prevent trapped air from circulating. So the fibres So because air isn't circulating, this will stop convection currents forming. And because there's less heat transferred to the outside wall, it will reduce convection onto the outside of the building. Okay, so fibres of the insulation prevent the trapped air from circulating, which stops convection currents forming. Due to there being less heat transfer to the outside wall, there will be reduced convection on the outside of the building. Okay, if you have time, try and complete this challenge question. So we're going to start the exactly same way by highlighting key bits of information. So the diagram shows some water being heated in a metal saucepan. Explain in terms of particles, so we know we're talking about the particles, how heat is transferred all the way through the water by conduction and convection. So make sure you talk about both. Okay, I want you to have a go at this one yourself, but to make sure you talk about, so conduction, we're talking about the metal saucepan, and convection will be in the water. And because we're talking about particles, remember to mention kinetic energy. So now pause the video and have a go at that. And well done for focusing on this lesson.